Hello to everyone and welcome to another marine engineering video. Today we will talk about start air system for engines KLS50 to 70 MC. And this program I have found from my colleagues on board the ship. I try to take some of programs if they like to share, and this program was developed by Singapore Maritime Academy, and here also we have a sign of MAN Diesel. So we have these files here, these files which have a lot of important information, and we have some basic, some familiarization, simulator, maintenance, and at the end we have a assessment. Okay. First of all, we will start from these basics to see, and we will talk for reversible engines, okay, with fixed pitch propeller. There is also some other kind of engines which is non-reversible engines, which have controllable pitch propellers. That means that engines turn always in same direction, okay, and we will talk here and we will see how the system is work. Okay, this is how it looks like, all the system. Okay, this is all the parts, and we will give here, we have an interaction with the system. We will give a signal ahead, so signal comes from engine console, passing to air distributor timing, to fuel injection timing here, ahead, rotation will have indication, to starter distributor, to reversing mechanism, and also we have a reversing interlock A here. Okay, we have give in ahead position. Next we will start with compressed air. Okay, let's see. Okay, the signal passing here, turn gear interlock checked, air fuel interlock checked. It's very nice. Okay, and starting air, it's on the way. Okay, the engine is turned by the air now. As you can see here, the starting air valve is open. This is our starting air distributor. Okay, and our propeller is turning on air. Now our reservoirs are almost empty, so we give the sending speed signal. So from the control room console, okay, we will set to dead slow, and a signal will go to the governor, and the governor will deliver to the fuel pump, so we will have an ejection. Let's see. Okay, we give to dead slow, desired speed, slow, half, and now we have ignition here, we have injection. And for stopping the engine, let's press stop the engine. Okay, let's stop. We go to half, slow, dead slow, stop. Okay, and the signal go to air fuel interlock B, puncture valve, fuel pumps, and through that we cut the fuel to the engine, so our engine stops. So let's go to continue to another basic. Okay, we have here starting air distribution timing. Okay, we can see how it works if we set to ahead. The air travels here, press these pneumatic cylinders, passing through pneumatic valves, and we are ready to ahead direction. In a stern direction, this is what is happening. Okay, change position, and that is it. Here we can see a diagram of when starting air valve open and closes. We have top dead center, bottom dead center, and this is probably is our cylinders. Okay, where will be first the air inserted in which cylinder. And in a head position, as you can see here, it differs, it's changed direction. That means if in previous diagram the number 3 cylinder, which is atop dead center, will be turned to that side, on a head position, if the engine is started like that, number 3 cylinder will be here, okay, and will push from top dead center down, okay, and next number 2 cylinder, it depends from the sequence of the engine, okay, the firing order. Okay, let's see also in astern here, in astern position, number 3 will be in the other direction. So this cylinder will be acting until here, okay, and then the starting air valve will be closed. So let's moving to the fuel pump timing. Okay, that is it here, where we have a change on a head astern position of the cam. Okay, because also the cam will turn in other direction, okay. So in astern position, the position of the cam will be like that. Okay, this device, the reversing device here, and in a head position will be in that position. Okay, same diagram here as before. The cam is, as we see here, is special shaped, okay, in the way to reduce the angular shift of the follower and install a simple and practical reversing arrangement of shifting the follower. So you can read here any information you like. We have also here indications of astern or a head position, the signal which is transferred also to engine control console and local. Next we will go to the scavenging and exhaust valve. It's not, we do not have any time changing, okay, no change in time we have also here. And next we go to interlocks. We have some interlocks, which is like a system to verify that everything is fine before make some fuel injection, also that our turning gear is out, okay. That is why we need these interlocks, also to prevent some hazard to make damage to our engine, okay. There is always some protective equipment for us, maybe we forget something, and there is always there to help us. That is very, very important. Also we have a safety system here, which in some problems will activate slowdown or shutdown. Let's see what happens when we send a signal of slowdown. Okay, I just press the signal of slowdown. Okay, slowdown is activated. The governor receives a signal to half slow and then dead slow and stop, and wait a moment, slow, yes, to slow. It's already received. Also we have here indication, yes, we're going on slow down. And also if there is a situation which the system doesn't approve further working of the engine, will activate shutdown, okay. And let's press shutdown to see which direct interacts on puncture valve and the fuel pumps, and then the engine is stopped. So we need to reset. We make a manual reset, okay. So air fuel interlock B, puncture valve and fuel pump, so we can start our engine again. If we not make reset, it's probably that our engine will not start. So let's see next the causes, okay, of shutdown and slowdown. The following faults will cause immediate shutdown. The engine overspeed, as you know, is very important. Main and thrust bearing low oil pressure. Thrust bearing high temperature. This is for shutdown. This is for sure. Most of the systems must have these alarms because they are very important. And for slowdown, here we have high temperature, boil oil inlet, piston cooling oil, main and thrust bearing, cooling water inlet, scavenging air, exhaust gas, high oil mist, piston cooling oil, main thrust bearing oil. Maybe your system have something different, have some less or more, but this is the main causes, okay? And if you ask me what I have seen on my engine, that was exhaust gas, also high oil mist, but high oil mist was from some sensors which was activated, some of the oil was entered there. That's why we cleaned the sensors. That was only from the part of the sensor, okay? It was not really increase of bearing temperature or really facts for high oil mist, okay? Let's go to basics, control of the engine, okay? And here we can see from where we can control the engine. We can control from the bridge, from the control room, and local to engine emergency control. Let's go now to main menu and we'll go to familiarization. Here you have all the systems, and as you can see there is a mark here, okay, a question mark, where you can press and you can see what exactly is each part, okay, and where is located. So we press interlock gear, interlock C, and direct the system. We have all the air system diagram here, pointed here, okay, 115. So we go there, we can see that this is 2-position 3-way valve, okay, and this blocks the start possibility when turning gear is engaged, okay. As you know, and you have always set your turning gear, you listen at the moment when you set your turning gear a noise like psh. This valve interacts, okay, and it's locked, the possibility to blocks the possibility to start the engine, okay. That is it. So this is very nice system. Here you can have this program from your colleagues, and I believe in the ship you will find that, so you can stay here and check one by one where is all the parts, okay. Here is the control room console. Let's go back. Okay, fuel pump, it shows here, okay, and as you can see there is a lot of parts of pneumatic valves, actuators, pistons, and also we can see here, okay, we'll go to main menu, we can see a simulator, okay, which will be operating in remote operation here, okay. Let's see, let's say that everything is ready, our turning gear is out, we have pre-loop our engine, everything is ready for start, and we give a signal for start ahead, okay. And let's see, the signal goes from here, goes to actuator, here to the air distributor, to reversing mechanism, okay, to secure that we have selected the head position, okay. The piston is pressed here, and then the signal is go to the air distributor, also the air here it's opened, and our valve here, starting valve, opens. So our engine is turned by air, 10 RPMs. Next we give to minimum, next order goes here, close the air, okay. Where is the signal? also, let's see, okay, we have 15 RPM. As you can see here, also our injection inject. Okay, let's give to medium. Okay, now the governor gives more fuel, and let's give to maximum, and let's give to stop to see what is going on. Okay, a signal stop here is going from this valve, air valve, here, then splits, go to fuel punctures, close to air distributor, and go to the puncture valve to the fuel pump to cut the fuel. Okay, so our engine is stopped. And now let's see the opposite direction to astern. Let's see, the signal will flow from here, from astern. Let's see it. Okay, activates to astern position. Okay, change direction here, air distributor, also reversing mechanism, and start signal, it's go here to this valve. Okay, to starting air distributor, open there, here. You can see all the valves working here, and now we're running on air. Start, when RPM increased, we can set to minimum. Okay, the RS is closing, and the governor gives fuel to our engine. So again, stop signal travels here, will go here, and one part will go also here to the air distributor to secure that is closed, and also to the puncture valve. It's a very nice program, and it's very necessary to see how it works, all the valves, okay, to identify. Okay, this is here, this signal shows that the air is passing from here it's blocked, and it's changed the position this side or this side. Okay, and also you can see the description here, throttle non-return valve ensures a good start of engine. Okay, delayed about 1 second. It's very quick, that system, because also this system have some small air receivers, 20 and 40 liters, as you know, which is below the second platform, that reduces the time in lags in the maneuvering system. Okay, that's why this system, it's very quick, also through the pressure, also through the capacity. Always this system is full and it's ready to operate. Let's go back here, and we see the local operation. Okay, change over with stopped engine. Okay, we have two choices. Also change over to local with engine running. Okay, let's see first change over with stopped engine. Okay, let's see. Okay, we can see overview here, and we have direct instructions what to do. Okay, I will follow the steps. Step 1, we inform the bridge that the engine will be maneuvered from local. Okay, next is change over fuel pump control. Okay, so we take local. Okay, we give, let's see next. Okay, we will have an ahead. Okay, in ahead. Okay, valve 102 must be activated. We'll take in local. So you can see also there is a hand here, okay, which shows how the signal goes. It has changed direction, okay, because other valves is interacted. Ensured that here is in the ahead position. Also the puncture valve here, and then we go to start. Okay, we'll increase to minimum and start. As you can see how signal goes here. Okay, starts. the air goes inside. Okay, we have 10 RPMs, and we need to release the start because our engine is running now. As you can see, we have also injection here. We can increase to medium. This is a simulator, a nice simulator to see how the flow is going, and when we press, how it goes. In the manuals of the manufacturer, sure, you will have this diagram all, but you will need to find how the air is going. Okay, let's close it, let's go back, and we will change over with engine running. So our engine is running with 7 RPM. Okay, we inform bridge that we will take local control with engine running. Okay, we test also the communications. Adjust local control for present running direction. Okay, let's see that where we're running, what direction. Let's see. Okay, astern, it's on astern position. Okay, it's astern. Here we don't change nothing, as it is. Next, we will take the control local. We're going to ahead. Okay, we change to ahead. Move the speed regulating handle to the maximum. Yes, because we have 70 RPM. We will move to the maximum. Local control. Correct. Next, we set local here, and a signal is activated, so we can stop and also give signal to maneuvering system when engine control is on emergency control. Pressure switch is activated here. Okay, as you can see, disconnects reset function and cancelling functions in the remote control system from safety system during emergency control. This pressure switch. Okay, we stop the engine. Let's say we need to stop the engine. Emergency stop. So okay, that is it. And the RPMs go down. As our puncture valve is secured, our air distributor is secured, and also it's verified the reverse mechanism, our engine is reduced on the speed. So it's very nice simulator if you like to find. And also this simulator, it's very light program. I will take this simulator with me in my hard drive. Okay, and if in case, okay, we have a start fail, in case of unsuccessful start, engine casing to run on fuel, it is possible to increase starting fuel signal by cancelling the fuel limiter switch 79 and make a new start attempt. Okay, the fuel limiter increases the fuel racks in a controlled manner. This is the main purpose of fuel limiter. And turbocharger, as the turbocharger speed up and build up scavenging pressure in order to prevent black smoke. As we know, a sudden increase of fuel amount will produce this black smoke, okay? And we don't like that. We like our engine to increase the load steady, okay? Steady and step by step, not very fast. If you can see also some cars, diesel cars, if they increase very quickly, you can see this smoke come out through the exhaust. Let's see also crash stop. Okay, there is possibilities to operate from bridge, from engine control room, and local control from engine side. This is the procedure here. Acknowledge the telegraph, give the engine a stop order. The engine will continue to rotate at slowly decreasing speed because the velocity of the ship through the water will drive the propeller and thereby turn the engine. Check that the limiters in the governor are not cancelled. When the engine speed has fallen to the reversing level of 15 to 30 of maximum continuous rate speed, depending on engine size and type of the ship, give reversing order, give start order, give when the start level is reached on the opposite direction of the rotation 8 to 12 maximum continuous rate speed, give order to run on fuel. This is maybe the quickest procedure to make reverse, okay, to avoid a crash or something else. But also it's good to discuss with engineers. It's a good practice to discuss with older engineers to learn something from there if they have any case of that, so new engineers to be prepared. And this is the purpose, for the reason we make these videos and we share our knowledge, okay, with all this channel. So also very important is the maintenance, which we need to do in some kind of time and where we are available also, because now the ports demand a lot of new regulations and a lot of inspections and like that. When we have time, we need to check that valves, okay. And also very important is supply of clean air. Air bottles must be drained daily, filters must be cleaned regularly, automatic water traps must be emptied regularly, okay. So we need to avoid oil in the system, water, we need to avoid some debris, some particles, and the proper pressure must be set from the reduction unit here. As you can see, this is how like the reduction unit, okay. And also I have to share you one experience that I have faced in one ship, that the air bottles, okay, was drained, but the filter, the control air filter was dirty, was really stuck up. Also the filters, which is automatic filters, was very fine, was also dirty and was not really replaced. And also the dehumidifier was not working properly, and in one ship the crew avoid to use that because they do not know how to operate the system. And as we know, as our experience has shown, this system is very important to keep reliable all the function of your valves, okay. So cleaning of the valves, this is very important. Also, let's see, the electrical contacts must be checked, that is in good condition, the switches, and there is a possibility to replace worn components inside of these pneumatic valves, which is contained from O-rings. This is how it looks like, the O-rings, and the pistons which activate these pneumatics. Also, as I have seen here, there is a indication from the manufacturer that it's better to change every 2 years that O-rings. Also, it's very good practice to test your engine to reverse, to make a head and a stern before arrival in the port, to check that everything is working. Okay, this is if you have a leaking piston sealing ring. As you can see, the air passing the other side and blows from the exhaust here. This is the spares, which always you need to have in case there is some problem. Also, there is some service letters, but we will not read them they describe exactly some problems that have faced some ships. Troubleshootings here also, it's very nice. We have also troubleshootings. Let's see that engine fails to start, okay? And here we have 13 possible causes and remedies which we need to do to fix that. Let's say that here shows valve on starting air receiver, it's closed. Open the valve, okay? This is the most obvious. And that is a lot of troubleshooting here. Engine fails to run on fuel. Shutdown of engine valve by 127, okay? Check the pressure and temperature, reset, shutdown. If the shutdown was caused by overspeed, cancel the shutdown impulse by moving the regulator handle to the stop position, whereby the cancellation switch closes and the puncture valves are vented. Okay, that is the remedies. And there is a lot. Okay. And let's see what is more. Okay, troubleshootings. As you can see, there is everywhere. These troubleshootings will be also in the manual of the book. Okay, they are sure they are located from there. Okay guys, and now I will make this assessment, okay, and we will see also if I make some mistakes, you will see the questions, the correct questions. Okay. This is to learn, okay? This assessment is to learn. It's not some test to see what you know. Also, it's for that, okay? It's for that, to see what you really know, and also to help to discover something that we didn't know, okay? So let's start the test. In the event of failure of main engine remote control system, the maneuvering can be carried out from, okay, local control, main engine, okay, and correct. Local control is provided to maneuver the engine if remote control fails. Ship crew must be familiar with changeover procedures, which requires regular drills. This is very, very correct. Next question. Difficulties have been experienced in getting the engine to reverse during maneuvering. The action you will take upon discovering the problem is to change over the local control to maneuver the engine, or inform bridge and request permission to investigate the fault. Okay, this is the correct answer. Any difficulties during maneuvering must inform the bridge so that they can take measures to secure the vessel. Yes, this is the reason why we inform the bridge and request permission. Okay, main engine fails to run on fuel but turns satisfactorily on air. The starting air pressure in air receiver is normal. Select 3 possible causes from the list given below. Okay, control air signal for starting does not reach the engine. Okay, the engine turns satisfactorily on air. We have air on receiver, and fails to run. Okay, that means something with the fuel. We do not have fuel, but it's run on air. This is very, very correct. Okay, engine shutdown is activated. Defective starting valves in cylinder cover. Okay, all the starting valves cannot be defective, okay? Some of them will work for sure. Okay, I will set this engine shutdown activated. Slow turning of engine adjusted to low. No. Slow turning adjusted to low. No, it's turning satisfactorily, it says. Engine is not warm. Okay, for the reason we need compression, and if the engine is cold, the compression will be lower of air. So the present speed setting is too low in this one. And is all correct, the engine would not run on fuel if the engine shutdown activates the puncture valves. Correct, no fuel is injected. If engine is cold, it will be difficult to achieve compression ignition. And C, if the present speed setting at the governor is too low, insufficient fuel will be injected for the ignition to take place. Okay, that means if the engine will not start here, we do not have something with fuel, but if it's running on air. Next question, number 4. Main engine fails to turn on starting air during maneuvering. Okay, when through it started satisfactorily during the previous start orders. Okay, it failed to start, but in previous orders it started. The pressure for the starting air and control air is satisfactory. Select the correct immediate action. Okay, cancel the fuel limit to give a starting air impulse. But this is from, but before it starts, okay, with that, and now it not starts. That means okay, we can check, we can give a short astern air impulse followed by a head air impulse, this one, and for the reason maybe it's stuck up, the distributor is sticking, and here it's quite possible that piston in the air distributor is sticking for a partial unit. By giving a short astern impulse, and starting air distributor will move to a different starting position and overhaul the starting air distributor at earlier opportunity. This is the answer here. Okay, let's move on. Local control can be achieved by change over to local control from control room, change over from local control from the local control station at the engine. This is the correct answer. Let's move on. It is possible for a marine diesel to continue to run ahead following the reversal of air distributor and fuel timing. Yes, it's possible. And the correct answer is during crash stop astern maneuvering, when ship's speed must be reduced quickly, the propeller may continue to turn in a head direction because the velocity of the ship through the water will drive the propeller. Okay, if the engine timing has been set for astern running, injection of the fuel into the engine that is still running in a head direction will continue to run the engine in same direction. The engine will experience very high exhaust temperatures in all the units, and wrong direction alarm is provided to alert the engineers of this abnormal condition. So let's move on. If the turning gear is engaged, then the engine cannot be turned on air. Okay. If the turning gear is engaged, the air to starting air system is blocked to prevent engine from turning and damaging the turning gear. If the lubricating oil pressure is too low, then the engine can be turned on air, running on fuel, only on air. If lubricating oil pressure is low, the engine can turn on air, but fuel won't be injected because emergency stop solenoid is activated, which operates the puncture valves. Okay, that is it. So you can make these tests so you remember what is happening if you have a lubricating oil pressure oil that the engine can run only on air, because the emergency stop solenoid is activated, which operates the puncture valves. And last question here is, safety system monitors the engine speed as well as critical pressures and temperatures such as oil pressure, temperatures. If present limit for these parameters is reached, a stop signal is given to governor, an emergency stop solenoid is activated, which operates the puncture valve. And in an emergency to save the ship, engine shutdown can be cancelled by how we can cancel the engine shutdown by answering the telegraph. No, this is the correct answer, that by pressing the shutdown cancel button. Correct. A shutdown bypass switch is provided on the remote control station to continue running the engine and maneuver the ship to safe location, even if emergency shutdown has activated. But if you activate this button, you must know exactly the cause, or you must be on emergency, something like that, okay, to activate and bypass this alarm. So guys, check for that program. Read also the manual, which is very important. Stay a little bit to check all these parts, the most of these parts here. It's sure that you will not remember everything, but it's good to know how it works, that system, and how you will read the system where it's needed. I had a experience. I faced that one of the starting air distributor valve was closed by vibration. That was a valve, old type valve, ball valve, simple ball valve without any lock mechanism, and that valve was closed and the engine cannot start, okay. And while I was apprentice engineer there in that ship, and I opened this kind of diagram, and I was looking how the line is going and where it's connected and from where it started, and to locate the problem, okay. And immediately I think that the first thing where the air is going is to air distributor, and which is very important. And also have some indication that engine is not turning either astern, either ahead. And also I was very proud that I find that problem even as apprentice engineer, and no one in the ship was not really fast to identify that problem. That happened before a lot of years in 2006. And always we must listen our crew, even if it's apprentice engineer or third engineer or oilers or second engineer. Everybody must be a team to listen each other and share whatever they have seen. Maybe one small thing that somebody observe, it's very important, and it's very important also to stay safe and secure.